Welcome to lesson 2.1.2, review and preview. We will be going through all of these questions, and if you need some help with any of it, please leave questions in the comments below and I will get back to you. Let's just jump right in. Okay, on 2-19 it says examine the diagrams below. What's the geometric relationship between the labeled angles? What is the relationship of their measures? Then use that relationship to write an equation and solve for x. Well, part A, they are vertical angles, which means that the angles that are marked are congruent. Okay, so we're going to set up an algebraic equation with that. Because they're equal, I can go ahead and put those markings there so that shows that. And I'm just going to set up 3x plus 5 equals 5x minus 57. Okay, and then I'm just going to subtract 3. I do this all in one shot. So subtract 3x and add 57. So it's going to be 2x equals 62 because I'm adding 57 to 5. Then I just divide by 2, so x is going to equal 31, okay? It's probably a good idea to get in the habit of doing a couple steps at once, because as you get farther into Algebra 2 and pre-calculus, it sure doesn't hurt to save time by doing 2 algebraic steps at once. Okay, so that points out that's part A. Part B, these two angles form a linear pair, which means they are supplementary, not congruent, but supplementary. So they add up to 180 degrees. So our equation will look a little different than part A, where we just set them equal to each other. On this one, we're going to have to go 4x plus 150 plus 2x equals 180. Okay, so I'm going to combine like terms. All right, then we subtract 150 from each side. Then we divide by 6 and x equals 5. Okay, and that helps you solve for both part A and part B, and hope that helped. Remember, if you got questions, leave them in the comments. Moving on. Okay, so on part A here, it says, how can you tell which angles have equal measures? For example, in the diagram at the right, which is our little isosceles triangle here, which angles must have equal measures, and name the angles and explain how you know. Well, because we have these two sides are congruent, that means the angles opposite those sides are also congruent. Okay, so that means angle B is congruent to angle C, because this is an isosceles triangle. Okay, so that helps you that part of it. But then it wants to know, it says, if measure of angle B plus measure of angle C equals 124 degrees, then what is the measure of angle B? Well, we can temporarily put in an x for each of these because they're congruent. So x plus x equals 124. All right, and I could put more notation in because they are both congruent, but it just means 2x equals 124, which means that x is going to equal 62 degrees. And that makes sense, because if I plug 62 in for measure of angle B plus 62, measure of angle C, because they're equal, it does equal 124 degrees. So hopefully that helps. Okay, that's part B. Part C, a little different, but we get to use some of the same properties to help find it. Because again, these are equal. That means this 71 degrees and this angle also is 71 degrees, okay? But we're trying to find x. So this forms a linear pair. Because of that, they are supplementary. So we're going to set up an equation that says 71 degrees plus x equals 180. Then we're going to subtract 71, and that will give us 109. So that means x equals 109 degrees. Okay, so we'll put that in there, 109 degrees. All right, that ends 2-20. If you have any questions, again, leave them in the comments. Moving on. Okay, so this is 2-21, and they have given us an e-tool for this, so I'm just going to do this little video that answers the question. So it wants us to plot these points and then do a translation of those points. But first it wants us to figure out what kind of quadrilateral it is. So first I'm going to go ahead and I'm going to plot the points. So -1, 3, And these by the way, these e-tools that they give you are pretty amazing and helpful. So use them when you have a chance. So there's 4, 3, and then it wants 4, -2, and it wants C, -1, -2. Okay, I'm looking at this, and right away I know it's a square. All 5 sides are the same. Everything's vertical and horizontal, so it's a square, okay? But now what it wants us to do is it wants us to translate the quadrilateral 3 units to the left and 2 units up. So I'm going to take each point one at a time. 3 to the left and 2 up. There's 1. Then I'm going to go over here and I'm going to go 3 to the left, 2 up. C, I'm going to come over here, 3 to the left, 2 up. And then last but not least, D, 3 to the left and 2 up. That finishes the translation of 3 to the left and 2 units up. So let's go and figure out what our points are. I'm going to go ahead and label those on the video so you see them. So point A prime is going to be -4, 5. So we'll say -4, 5. Okay. And we'll label that point so you can see it. If I can get my mouse over here working for me. All right, so there's 1. Then let's do the next one, which is B prime, and that's going to be 1, 5. So 1, 5. Okay, and I'm going to change it to red just because all the others are red. So I'm kind of showing you some technology here while we're doing it. And again, I want to label it. Okay, then I'm going to go down to C. And that one is just -4, 0. So we're going to go -4, 0. Change the color because I just have to have them all be red. And then we're going to hit the label. There you go. And last but not least, our D prime. Okay, and that's going to be 1, 0. So 1, 0. And again, I'm changing it to red just so they're all the same. I know I keep saying that and you're like, okay, we already know what you're doing. All right. And there you go. That's what you have is the translated shape, all prime notation. If you notice that A prime, B prime, because these are A, B, C, D. These are A prime, B prime, C prime, D prime. And all of the new points are labeled. So hopefully that helps and we'll move on. So in this problem, it says find the equation for the line that passes through -1, -2, and 4, 3. Is the point 3, 1 on this line? Be sure to justify your answer. So I'm going to show this to you algebraically, and then I'll show you what the graph looks like. But let's do this algebraically first. So I'm looking to fill in information for the slope-intercept form of the equation. And so we'll start by just reminding you of what that is. Y equals mx plus b. Well, in order to find parts of this equation, first I'm going to find the slope, and that is m. So m is going to equal, if you remember, it's y2 minus y1 over x2 minus x1. So I'm just going to go ahead and calculate that for this set of points. And that is, I'm going to take y2, and you could do y1 minus y2 also, as long as it's x1 minus x2 on the bottom. So I'm going to say 3 minus a -2 over 4 minus a -1. That will give me 5 over 5. So I know that it equals 1. So my slope is 1. All right, now I can take either of these 2 points and plug them into the y equals mx plus b equation. And so I'm going to choose 4 and 3 because I'd rather not work with negatives if I don't need to. So on my y equals mx plus b, I'm going to plug in my 3 for my y, my 1 for my m, because that's my slope, and my 4 for x, so that I can find the y-intercept for our equation. So that is 3 equals 4 plus b. We subtract 4, so that it's going to end up equaling -1. That's our b. So now we have an equation. So our equation for this line will be taking the slope that we have found and the y-intercept that we have found here, and our equation will equal y equals x minus 1, because this is 1, okay? So that's our equation. I'm going to go ahead and erase that. And now it wants to know if our 0.31 is on it. So what I'm going to do, if I plug 3 and 1 in, then I should have two sides of the equation that equal each other. So let's plug my 1 in for y, and then my 3 in for x. Well, 1 does not equal 2. So therefore, we know it's not on the line. So let's go ahead and look at the graph and see what the line looks like and what the point looks like plotted. And I'll get that for you right now. So here's a picture of what that graph looks like. You can see the y-intercept is down here. Oops, I'm moving that around. There we go. And then you can see that it goes up 1 over 1, up 1 over 1. But then you notice here's our line and here's our 0.31. So this just verified our work that we did on the left. All right, now we're moving on. Okay, so this is the final problem on lesson 2.1.2's review and preview. And so we're just going to kind of jump into it and show you the drawings that you should be getting when you have a certain rotation. So Juan decided to test what would happen if he rotated an angle. He copied the angle at right, and now it's actually, if I go over here and get my pen, it's down here. It's not at the right. I needed more space. Anyway, what type of angle pair did he create? So if I am rotating this line 180 degrees, it's going to go straight off here. Sorry, I'm into the words there. And if I rotate this line 180 degrees, it's going to go here. That creates a vertical pair of angles. And they are congruent or equal in measure. Hopefully you can read that writing. Equal in measure. Okay, so that takes care of part A. Part B is a little different. We are rotating around this point. So if I'm rotating this particular shape 180 degrees this way, I am actually going to have a Z. So if I come through here, it's going to come down like this and rotate that direction. So hopefully that helps, but that is how you do. So this is part B down here. And that is how you end and do the rotations for 2-23. If you have any questions, again, leave them in the comments section and I will get back to you. That ends this whole review and preview. So again, if you like this video, please consider subscribing and at least give us a thumbs up maybe if you felt like you learned something from this. And we'll see you on the next video. Thanks so much. Bye.